Right, now I would like to show you how to add together the value of capacitors in parallel and calculate the energy and the charge in the circuit. So if we start with 3 capacitors in parallel, I use the same as I used in the series circuit. So C1, C2 and C3, all in parallel across the supply, and we'll call the supply again VS, voltage supply, and again we'll have the same values as we had before, so we'll have C1, C2 and C3 and VS equaling 10 volts for the supply, 0.2 microfarads, 0.5 microfarads and 0.4 microfarads as before. And in the case of the parallel capacitors, we can just add them together, physically add the numbers together. So the total capacitance CT will just be equal to C1 plus C2 plus C3, which will be 0.2 microfarads plus 0.5 microfarads plus 0.4 microfarads, and of course that will equal 1.1 microfarads. Oops, forgot the F. To find the energy, first of all let's find the charge in the circuit. Remember that Q, charge in coulombs, is equal to C times V. We just multiply the total circuit capacitance, which is 1.1 microfarad, times the 10 volt supply across them, and that will give us 11 microcoulombs. Microcoulombs because we're dealing in we're using microfarads. Right, now I want to find the charge in each capacitor. Well, in this case the charge in capacitor 1, let's call it Q1, will be equal to the value of the capacitor C1, that's 0.2 microfarads, times the voltage across it. Now in a parallel circuit they all have the supply voltage across them, they all have 10 volts, so this is going to be times 10. So that equals 2, and because it's going in microfarads, that'll be microcoulombs. 2 microcoulombs, Q2, 0.5 times 10, 5 microcoulombs, and the charge on capacitor 3 is 0.4 times 10 equals 4 microcoulombs. So the total circuit charge can be calculated there by just adding them together, and that would be 11 microcoulombs, and that figures because we have 11 calculated above using the total capacitance and total voltage of the circuit. Lastly, I want to calculate the energy in the circuit as a whole, and also calculate the energy in each capacitor. And to do that I'm going to use, I'll just slightly refocus, E equals a half C times V squared. Now for the energy in capacitor 1 we'll call E1, that equals a half times the capacitance of C1, that's times 0.2, I'm going to keep it in microfarads, times the 10 volts that it has across it, and that's 10 volts squared. So this is 0.1 times 100 effectively, or 10 microjoules. The next one, energy in capacitor 2 is a half times 0.5 times 100, 10 squared. So that becomes 2.5. So no, 25, sorry, 25 microjoules. And the energy in capacitor 3 is equal to a half times 0.4 times 10 squared, so that will be equal to 20 microjoules. If we add all of those together, we get the total energy in the capacitor in the circuit. So that's 10, 30, 55 microjoules. We could also calculate that, let's go on the F at the end here, but just say ET for total energy would be a half times the total circuit capacitance, which we calculated above as 1.1 microfarads, times the voltage on the circuit squared, and that therefore also comes out at 55 microjoules.